Good morning to all. Today we are discussing about transformer equivalent circuit in per unit form. The equivalent circuit of a transformer referred to primary side shown in figure 2.26a. The equation in terms actual values V1 is equal to I1 into Z equivalent plus V2 dash 2. The equation in per unit system can be obtained dividing equation throughout by the base value of the primary voltage V1 divided by VR1 is equal to I1 into Z equivalent 1 divided by VR1 plus V2 dash divided by VR1. That is equal to I1 into Z equivalent 1 divided by IR1 into ZV1 plus A V2 divided by A VR2. Then V1 per unit is equal to I1 per unit, Z equivalent 1 per unit is equal to V2 per unit. The first parameters in the circuit diagram, then V1 input I1, R equivalent and X equivalent. Then second diagram, V1 per unit, I1 per unit is equal to Z equivalent per unit. Then V1 per unit, I per unit is equal to Z equivalent per unit is equal to V2 per unit. Transformer equivalent circuit in per unit form. Full load copper losses. Power copper losses of full load is equal to full load copper losses I squared R1 plus into R equivalent 1. The full load copper losses in per unit uniform based on volt ampere rating of transformer. Copper loss per power full load is equal to I squared R1 into R equivalent divided by B base. I squared into R1, R equivalent 1, VR1 divided by into IR1. R equivalent divided by VR1 is equal to divided by IR1. R equivalent 1 divided by ZB1 is equal to R equivalent per unit. Hence, the transformer resistance expressed per unit form also represent the full load copper losses per unit form. The per unit value of the resistance is therefore more useful than its ohmic value of determining the performance of a transformer. Transformer in parallel. When a growing load equality exceeds the transformer rating installed transformer, we sometimes connect a second transformer in parallel with it to ensure proper load sharing between two transformers. They must possess the following. The first point, the same primary and secondary voltages. Second point, the same per unit impedance. Particularly, attention must be paid to the polarity of each transformer so that terminals having the same polarity are connected together. A error polarity produces several short circuits as soon as the transformer excited. In order to calculate the following in each transformer, they are connected in parallel must be first determine the equivalent circuit of the system. Consider the first equivalent circuit of a single system, primary voltage and the impedance of the transformer refer to the primary side. If the ratio of the transformation circuit can be simplified as shown in figure, procedure already familiar with. If a transformer second and impedance is connected to the parallel equivalent of become, in effect impedance of the transformer are in parallel, the primary current in transformer respectively I1 and I2. Because of the voltage drop across the impedances can same return. Then I1 ZP1 is equal to I2 ZP2. I1 is equal to ZP2 is equal to I2 is equal to ZP1. The ratio of the current transformer therefore determines the magnitude of the respective primary impedances and not by the rating to transformer, but in the order of temperature rises with the same both transformer current must be the proportional to the respective kVA rating consequently. We want to fulfill the following. I1 is equal to S1, I2 is equal to S2. From the it can readily provided that desired condition met if a transformer same per unit impedances, the following shows what to happen, the per unit impedance difference. Transformer tapes. Due to voltage drop transmission line, the voltage particular region distribution system may consistently be lower than normal. Thus, a distribution transformer ratio 2400 volt divided by 120 volt may be connected transmission when the voltage higher than the 2000 volt. Under this condition, the voltage across the secondary is considerably less than 120 volt. Incandescent lamps are dim. Electric stoves take longer to cook food. Electric motor may be under moderate overloads. To correct the problem, taps provided on the primary winding of distribution transformer, the enable has changed to the transformation ratio so as the secondary voltage ratio 4/2 or 13/2%. We can there maintain satisfactory secondary voltage through the primary voltage and 4/2, 9 or 13/2% below normal. Thus, referring the transformer if the line voltage is only 2076 volt instead of 2400 volt, we should use terminal as 1 to 120 volt on the secondary side. Some transformers are designed to change in the tap automatically whenever secondary voltage above below preset level. Such tape changing transformer help maintain the secondary voltage with plus or minus 2% of rated value throughout the day. Thank you.